Hello and Assalamu alaikum. In this lecture, we are going to discuss 8086 registers. Let's start the lecture. So let's discuss what are registers first. So registers are high-speed storage locations directly inside the CPU designed to be accessed at much higher speed than conventional memories. These registers are grouped into three categories. Category number 1, segment register. Category number 2, journal registers. Category number 3, control registers. Let's talk about the first category of registers, that is segment registers. Segments refer to the specific areas designated within a program to hold data, code, and the stack. There are four major segments. First is the code segment. So code segment contains all the instructions to be executed. A 16-bit code segment register, also known as CS register, stores the starting address of the code segment. The second is data segment. It contains all the variables or data. A 16-bit data segment register or DS register stores the starting address of the data segment. The third is the stack segment. It contains data and return addresses of subroutines. A 16-bit stack segment register, also known as SS register, stores the starting address of the stack segment. Fourth and the last is extra or extended segment. It is used to store variables in case the data segment is not sufficient to store all the variables. A 16-bit extra or extended segment register, also known as ES register, stores the starting address of the extra or extended segment. Now let's discuss the second category of registers, that is journal registers. The journal registers are further divided into the following three groups. First, data registers. Second, pointer registers. Third, index registers. First are data registers. Four 16-bit data registers are used for arithmetic, logical, and other operations. Number 1 is AX, known as accumulator register. It is a 16-bit register in which intermediate arithmetic and logic results are stored. Number 2 is BX, known as base register. It is a 16-bit register which can hold the address of a variable or can also be used as an AX helper for arithmetic and logic operations. Number 3 is CX, known as counter register. It is a 16-bit register which acts as a counter for loop instructions or can also be used as an AX helper for arithmetic and logic operations. Last, number 4 is DX, known as data register. It is a 16-bit register which can be used to store data for I/O operations, and it also can holds the high 16 bits of the product in multiply or holds the remainder of the divide operation, or it can also be used as an AX helper for arithmetic and logic operations. These 16-bit registers can be divided into two halves, AH and AL. Similarly, for BX, it can be divided into two equal halves, that's BH and BL, and so on. AH is used to store the most significant 8 bits and AL is used to store the least significant 8 bits of AX. For general knowledge, do remember that R in any data register represents 64-bit, E represents 32-bit, and AX, BX, CX, and DX represents 16-bit architecture. Next are pointer registers. Two 16-bit pointer registers used in 16-bit architecture are SP stack pointer and BP base pointer. Number 1, SP. The 16-bit SP register is the stack pointer used to manage push and pop operations. It points to the top item of the stack and works with SS register. Number 2 is BP. The 16-bit BP register is the base pointer mainly used to access parameters passed to the functions. It also works with SS register just like stack pointer. Third are index registers. Two 16-bit index registers are used for indexed addressing and sometimes used in addition and subtraction. Number 1 is SI, known as source index. It is used to store offset address of source operand and it works with DS. Number 2 is DI, known as destination index. It is used to store offset address of destination operand. It works with ES. Both SI and DI registers are used in string movement operations. An instruction like move SB will copy a byte from the memory location pointed at or pointed by SI and move it to the memory location pointed at or pointed by DI and then increment both SI and DI. So if you want to copy the byte stored at SI plus 1 to DI plus 1, it only takes a further move SB instruction. Now let's discuss the third and last category of registers, that is control registers. The 16-bit instruction pointer register and flags register combined are considered as the control registers. Instruction pointer register is used to store offset address of the next instruction to be executed and it works with CS. While flags register is used to store the status value after arithmetic and logic operations that are tested by conditional instructions to change the flow of program execution. Commonly utilized flag bits are sign flag, overflow flag, direction flag, interrupt flag, trap flag, etc.